Welcome back. We will do some worked examples in these complex numbers, what we have up to the point that we have done so far. I will use these examples that's there in the book. The first one, if z is equal to -2 plus j3, find the argument, or say find the modulus z. So this is quite easy. Now z is equal to -2 plus j3, so that's the real part and that's the imaginary part. So if we just represent this in the Argand diagram, so that's your real axis, that's the negative real axis, that's the j axis, and that's the negative j axis there. So real part is -2, so shall we say it is somewhere there, say that's -1 and -2 -3 like that, and then j is 3, so if you take this as 1 2 3, that's positive. So this particular complex number can be represented by there, right? So that's z there, and modulus is the length of this vector or the magnitude of this vector, so which is equal to 2 squared plus 3 squared square root. Now please note that we will take only the positive value there because we need only the magnitude there. It's immaterial whether it is negative or positive. So that is square root of 4 plus 9, that is square root of 13, which is, if you use the calculator, that is 13 square root, that is 3.6055. That's the answer. So these sums involving this to find the modulus, that's quite easy. So let's take the second one. That's the first one, and this is the second one. That is if p is equal to 6 minus j, find modulus p. So modulus p is simply equal, we don't have to draw this, but if you need we can draw it. That is 6 squared plus 1 squared square root, so that is 36 plus 1 square root, which is 37 square root, and you can use the calculator to find the value there. Similarly, if you take the third one, there q is given as simply -5j. So if I use these earlier coordinates, you will see this -5j, say this q, point q lies somewhere there, so it is lying on the negative j axis. So the magnitude of that is simply that. So we can see the modulus is simply 5, right, because it's there's no relative real part there, so it's simply 5, because you can, if you want, you can show it this way: 5 plus 0 squared square root, which is again 5. So this is easy to find, this modulus. So let's go over to the next page and work the example number 3. If Z1 is equal to -2, -J3, and Z2 is equal to 4 minus J6, and Z3 is equal to 4 J4, we have to find Z1 modulus and Z2 modulus and Z3 modulus, and also Z1 minus Z2 modulus. So we have interesting one there, how to find this Z1 minus Z2 modulus. So let's find Z1 modulus, that is simply 2 squared plus 3 squared square root, because here that's the real part, that's the imaginary part. We take only the magnitude, we disregard the sign there. So that's simply 4 plus 9 square root, which is square root of 13, which we found earlier as well, which is 3.6055. And let's take Z2 modulus, that is 4 squared plus 6 squared square root, which is equal to 16 plus 36 square root, which is square root of 52, and we can find that using our calculator. Square root of 52 is 7.21. That's the answer. And let's take the third one. Z3 is just J4, so the modulus is simply 4 from what we have done earlier. If you want, I can do it because the real part is 0. So modulus is simply 4. Now let's see what is this, the last one, the modulus of Z1 minus Z2. So I will rewrite this Z1. Z1 is equal to -2 minus J3, and Z2 is equal to 4 minus J6. So we simply subtract Z2 from Z1. So that is, you subtract the real parts. So that is -2 minus 4, -2 minus 4, and then you subtract the imaginary part, J3 minus J6. So when you simplify, you will get this is equal to, that's -2, -4, -6 minus J3, and when you multiply this negative sign by the sign inside, that's positive J6. So that gives us -6 plus J3, because J3, negative J3 and J6 makes it J3 there. So now we can find the modulus, which is easy now. It's equal to 6 squared plus 3 squared square root. So that is equal to 6 squared is 36 and 3 squared is 9, and that is the square root there, that's 45 square root, and which is, from our calculator, it will be 45 shift, that's 6.708. So that's the answer there. So now let's move on to the next examples in the book. Example number 3. Find the argument arg z if z is equal to square root 3 plus J3. So this is our complex number. Now we know how to find the modulus of that one. Now we have to find the argument. So earlier I defined that if we have a complex number, that's the imaginary axis and that's the real axis. So if we represent this in this Argand diagram, say square root 3 is somewhere there and this is there, so it will be a point like that there, say z, and this is root 3 and this is 3, so this is the angle theta, and argument z by definition is tan theta, tan inverse theta, so that is in this tan theta is 3 over root 3, because that's the angle, this is a right angle triangle, and then tan theta is 3 over root 3, and theta is equal to tan inverse 3 upon root 3. So if you use the calculator, you can find this. So 3 upon root 3, that is 3 is equal to 1.732, and inverse, tan inverse of that, inverse tan, that is 60 degrees, so that is 60 degrees. So that's the argument. So let's move on to the next example. Example number 4. Find argument z if z is equal to negative root 3 plus J3. So this is we can see now is slightly different to the earlier one. The earlier one we had root 3 plus j3, but here it's negative root 3 plus j3. So if I draw the Argand diagram again, that's the real axis and that's the imaginary j-axis there, that's the negative j-axis, that's the negative real axis. So now you will see this real part is negative, so we'll take it square root 3 there, and still the imaginary part is positive, so like in the earlier one, so we will take it somewhere there. So we are actually talking about this vector or this phasor there, and now the angle, if you take on the clockwise rotation, so this is the angle that we have to find, but now it's easy to find this angle here. Shall I say this angle is alpha? So we know that this is square root 3 there and this is 3, so tan alpha is equal to 3 over root 3, and alpha is equal to tan inverse 3 over root 3, and which will give us this 60 degrees again, because that's what we found earlier. So we know now this alpha angle is 60, and then this from real axis to negative real axis is 180 degrees. So this angle is 180 degrees minus 60, which is 120 degrees. So the argument, we can say the answer is not 60 there actually. Argument Z is 180 minus 60, which is 120 degrees. That's the answer. And let's move on to a similar one, the next example. Example number 5. That's find argument Z if Z is equal to square root 3 minus j3. So now you can see these numbers are same, but then you will see that the signs are different, so we will have different vector or different phasor there. So we'll draw our Argand diagram again, and this is negative j. So Z will definitely lie in this third quadrant where both real part and the imaginary part are negative. So this is, say, square root negative square root 3, and j3 is, say, it is there. So we know our vector is this now, right? So we can now easily find this angle there. So shall we say that angle is another angle, say phi, right? So the angle phi, we can say tan phi is equal to 3 over root 3. It's actually negative 3 over negative root 3. So it will be again the same, just like in the earlier case. It will be 5 will be tan inverse 3 over root 3, which is 60 degrees again. Now what we do is, actually we don't measure it from the positive real axis clockwise direction. Now when you measure the angle to get this argument, if we take this as the positive direction, then if you take it on the other direction, we take it as the negative direction. So in the negative direction, now this is 60, but this angle will be 180 degrees minus 60, so it will be 120, but 120 in the negative direction. So we say argument Z in this case is negative 120. So that's the answer there. So important thing to remember is that if we take this direction as positive, that we always do, and then if you measure the angle in the reverse direction, we take it as negative. So that goes on to show that J, negative J, and positive real and negative real there. So if we have a angle there, shall we say theta again, this will be negative, it's a negative angle, right? Say if it is 60 or 30 or 45 or whatever, that's a negative angle. And if we measure it in the other direction, then that's a positive angle. So when you are asked to find argument of a complex number, you have to draw the Argand diagram and locate where the phasor is, and then you can go on, you can go about finding where the phasor is, and then the angle, whether it is a positive angle or a negative angle, and use the methods that we used above to find the angle. Thank you.